Okay, here we go. Why do we need inverse trig functions? Well, we've seen them back in geometry and in algebra 2. If you want to solve a trigonometric equation like sine x equals, 0.5761, you have to do inverse sine to do it. So, in order to have an inverse, a function must pass the horizontal line test. So, let's make a quick sketch of y equals sine x. Alright, sine starts at 0, goes up to 1, 0, negative 1, 0. Follow the pattern. We're getting really good at our sine curve. Now this does continue forever and ever to the right and to the left, but we're getting the gist of the curve. Does it pass the horizontal line test? No, it fails miserably. It intersects it numerous times. But what mathematicians have agreed upon is that we need an inverse sine to work. So, and we did this last year in Algebra 2, if you chop the graph and you restrict it from negative pi over 2 to pi over 2, that piece will pass the horizontal line test. So we can then have an inverse sine function. You can denote it in two different ways. Y equals arc sine x, or y equals inverse sine x. Then we're asked, what is the domain and range of the inverse sine function? Well, let's go back to our sine function. We have restricted the domain from negative pi over 2 to pi over 2, and the range is negative 1 to 1. Well, if you remember from Algebra 2, an inverse function is where you switch the x and the y values. So then my domain is going to become the range of sine x, which is negative 1 to 1, and my range is going to be negative pi over 2 to pi over 2. Okay, is this coming back to you a little bit? Alright, so if possible, find the exact value. So what you need to remember is the outputs are negative pi over 2 to pi over 2. They're angles. Now stop and think here a moment, because students will get this all mixed up. Negative pi over 2 to pi over 2 would be in what quadrants? Anybody? First and fourth. Okay, this is the first and the fourth. However, its values 0 to pi over 2 and 0 to negative pi over 2. So is it appropriate to say 5 pi over 3? No, because that's not in between negative pi over 2 to pi over 2. So let's look at letter A. It says arc sine of negative 1/2. The answer is an angle between negative pi over 2 and pi over 2. What I like to do with these is I like to rewrite it and say, okay, this actually means the sine of what angle equals negative 1/2. Well, if I'm only in the first or fourth quadrant, and I know all students take calculus, I know I'm not in the first quadrant, okay, because sine is positive there. So I now know I'm in the fourth quadrant, but I have to identify theta from 0 to negative pi over 2. So what would that be? Wouldn't that be negative pi over 6? Okay, we have got to get better at quick recall of our unit circle values, okay? Let's look at this one. Letter B. I'm asking myself the sine of theta equals radical 3 over 2. Well, my options are first quadrant or fourth. Because it's positive radical 3 over 2, I'm in the first quadrant. So what's the reference angle? What's theta?
60.
Okay, it's pi over 3. Something I need to mention is that inverse trig values are always radians. They're not in degrees, okay? Now, let's flip the screen back one page. And it says the domain, what's inside inverse sine or arc sine, has to be a number between -1 and 1. So suppose I'm on autopilot and I've shut my brain off a moment and I have sine theta equals 2. First of all, I know that that's not a unit circle value. But then let's go back to our graph. It's oscillating between -1 and 1. I can't get a 2 out of sine theta. Okay? I mean, it's in between here, like I'm not doing a transformation to the graph. So this one, do not put no solution, because inverse sine 2 isn't an equation. We're not solving the equation. We are finding a value or evaluating, but it's just not defined. Okay, you can say not possible, but don't use the empty set symbol or no solution. All right, let's do just a few more of these to make sure you're really getting the hang of it. So let's suppose I ask you for inverse sine of negative radical 2 over 2. Once you really get the hang of this, you start mentally doing, okay, the sine of what angle is negative radical 2 over 2. You want to figure out the reference angle. And then what's kind of nice about inverse sine is that if you figure that out, the negatives are just the negatives of it. That's it. Okay? So what would this one be?
7 pi over 4.
It can't be 7 pi over 4 because that's not a number between negative pi over 2 and pi over 2. Negative pi over 4. Do you see that? How about inverse sine of 1? What would that be? Pi over 2. And how about inverse sine of 0? It's just 0, okay? Because the sine of 0 is 0. Okay, example 2 says sketch a graph of y equals arc sine x. So I'm going to rewrite this as x equals the sine of y. The sine of y equals x. So what's the sine of negative pi over 2? Negative 1. If I do the sine of negative pi over 4, that's negative radical 2 over 2. The sine of negative pi over 6 is negative 1/2. The sine of 0 is 0. And this is 1/2 radical 2 over 2 and 1. Now, my table is backwards. I want you to notice that. My x's are in the bottom row, and my y's are in the top row. So, and when you're doing inverse sine or arc sine, those are interchangeable. Remember, the domain is now -1 to 1, and my range is negative pi over 2 to pi over 2. So this is going to be a little bit confusing when you're trying to use this table because they're reversed. Okay, well, I know what negative 1/2 is. That's negative 0.5. Take out your calculators and do radical 2 divided by 2. I've already done it. And that's going to give me about negative 0.707, somewhere around there. Okay? So watch what you're going to do. You're going to plot negative 1, comma, negative pi over 2. It's x, comma, y. Then I'm going to go negative 0.7, negative pi over 4. Negative 1/2 is negative pi over 6. 0, 0. Then I have 1/2 pi over 6. 0.7 is pi over 4. And 1 is pi over 2. Do you understand you're doing x, comma, y? And there's your inverse sine graph. Okay? So, trying to be very, very clear here that my table, the x's are in the bottom row, but you're still plotting x, comma, y. Alright, so these are all things inverse sine. Y it's negative 2, or negative pi over 2, pi over 2. How you compute it and how you graph it. Okay? Alright, let me give you a moment to fill in this chart. It says definitions of the inverse trigonometric functions. Number 1, y equals arc sine x. Does anybody remember what does IFF stand for?
If and only if.
Beautiful. If and only if sine of y equals x. The domain, we've already stated this, x is between negative 1 and 1, and the range is negative pi over 2 to pi over 2. In a moment, we'll graph cosine and look at its inverse. So y equals arc cosine x, if and only if cosine y equals x. X is between negative 1, wait a minute, my bad. This is supposed to be 0 to pi, sorry, that's 0 to pi. Can't believe I put that on. Sorry. I would have caught it. Yeah, that's supposed to be 0 to pi for inverse cosine. I'll show you why. And then number 3, y equals arc tangent x, if and only if tangent y equals x. X is a real number, and y is between negative pi over 2, pi over 2. That's not a typo. There is a no equals. And again, you'll see why. Alright, so let me do this. Just so I don't have to redo the work here. Okay, when you're looking at cosine, here's the graph, and it would fail the horizontal line test. So mathematicians have agreed on chopping it from 0 to pi. If you look at that piece, from 0 to pi, it would then pass the horizontal line test. So the domain is 0 to pi, the range is negative 1 to 1. So arc cosine, you just switch those. So now the domain is negative 1 to 1, and the range is 0 to pi. Now, 0 to pi is between the first and the second quadrant. So, you either need to memorize it, that inverse sine is negative pi over 2 to pi over 2, inverse cosine is 0 to pi, or make a sketch, and you can always figure it out. Okay? So I'd rather you do the second one where you're reasoning it out. So let's look at a few examples here. If I have arc cosine of 1/2, this means the cosine of what angle would give me 1/2. So what would that be? You guys should know this. Pi over 3. How about if you have arc cosine, let's go down, is negative 1/2. Good job. It's in the second quadrant because the outputs are 0 to pi. So it's 2 pi over 3. Arc cosine radical 2 over 2. Isn't that pi over 4? And then arc cosine negative radical 2 over 2. 3 pi over 4. Okay? So now, hopefully, this makes a little bit more sense why it was 0 to pi. So let's do an example 3, A and B, and we'll go back to tangent and finish up C and D. So we just did this one. Arc cosine radical 2 over 2. That's pi over 4. How about letter B? Arc cosine negative 1. Pi. Okay? All right, now let's look at tangent. Here's the tangent curve. And what's nice is if you restrict the domain to negative pi over 2 to pi over 2, not including them because they're vertical asymptotes, that gives me a piece of graph that will pass the horizontal line test. Then inverse tan, you're just going to switch those. So that's why the domain is all real numbers, and the range is going to spit out numbers between negative pi over 2 to pi over 2. So what's kind of nice is you can make a connection here that inverse sine, inverse tangent are really negative pi over 2 to pi over 2. But inverse cosine is 0 to pi. So it can kind of help you keep it straight. So now let's think about letter C. The tangent of what angle gives me 0? 0. The tangent of what angle gives me negative 1? And it has to be an answer between negative pi over 2 and positive pi over 2. So it's definitely fourth quadrant. So what would that be? Negative pi over 4. Okay? Alright, example 4 says use a calculator to approximate the value if possible. So in letter A, it says arctan negative 8.45. So let's take out our calculators. I've already done this one. Check your mode, make sure you're in radians. The only time you'll flip to degrees is in 4.8 when you're saying what's the angle of elevation. You don't usually describe to somebody, hey, the lighthouse has an angle of elevation of 0.237 radians. You know, there will be common sense problems. All right, letter B, inverse sine of 0.2447 is 0.2472. It really does not matter how many decimals you go unless the homework says go 2 decimals, 4 decimals. It really doesn't matter. Now, what's wrong with letter C? Why can't you do it? It's not in the domain, so don't fall into that trap. You can't have numbers that are bigger than 2 or smaller than, or bigger than 1 or smaller than negative 1. So this one is not defined, not possible. Okay? All right, then we're going to look at composition of functions. It says recall if f and f inverse are inverses, then we remember from algebra 2 that f of f inverse of x is x, and f inverse of f of x is x. So we're going to use this to help us. If x is a number between -1 and 1, and y is a number between -pi/2 and pi/2, then the sine of arcsine of x is x, and arcsine of sine y is y. It's essentially saying, like, if you're taking the square root of x squared, it's the x. So if you're undoing an inverse, it should usually give you the inside. But you've got to keep in mind that x and y are defined the way that they are. Number 2, if x is between -1 and 1, and y is between 0 and pi, then the cosine of arc cosine x equals x, and arc cosine of cosine y is y. If x is a real number, and y is strictly between -pi/2 and pi/2, then the tangent of arctan of x is x, and arctangent of tangent y is y. Okay, then I have this note, and this is pointing out something that, unfortunately, students sometimes just look at the end and forget the beginning part that was important. So I'm trying to point that out. It is saying if x is between -1 and 1, y is between -pi/2, pi/2, then the sine and arcsine will cancel, or arcsine and sine will cancel. Well, then why isn't that just equal to the inside?
Because y is outside the range.
Exactly. Do you see this y? So I'm actually looking at this piece right here. And it says arcsine of sine y is y, but that's provided that y is between -pi/2 and pi/2. Now, this doesn't mean you can't do the problem, but I'm saying the answer isn't 3 pi/2. So look, I can go to the inside. What is sine of 3 pi/2? That's actually a unit circle value. What is that? -1. Now, can I do arcsine of -1? Yes. What is arcsine of -1? That's spitting out values between -pi/2 and pi/2. -pi/2. So I'm not suggesting that you can't do the problem necessarily. It just might mean you have to do it differently. But you've got to meet these two criteria. What x can be and what y can be in order to do that. Okay? We are going to stop there.